Okay, we're going to take a look at practice question, one of the Hardy questions, number 1, page 6. So we talked about there's two ways to use the formula. We're going to try to do both of them in these examples in these next couple of videos and that, just so you kind of get a sense of how to navigate through these type of questions. So let's get right to the question here. And we're going to give you again some strategies on how to determine what the question is asking, different things to highlight within the question and that, just to make sure that you're doing these correct. So it says, suppose in a pea plant population, the frequency of the recessive allele. Okay, so the recessive allele here is the key point in this question here. So when they say the recessive allele, and then they give you that frequency, so they're saying the R is 30%. So this, when I see this, the recessive, that we know in our formula, our Hardy-Weinberg formula, is always going to be Q. And when we see this allele, that's giving us the single Q. And that frequency, what they're saying, equals 30%. So that's important to know what they're giving you, because when we do the other examples, sometimes you square root, and students often have a hard time determining when they square root, when they don't. So at this point, they've given you the frequency for the single Q value. And then they say, what is the expected 3 genotype frequencies in the next generation? So that's what they're asking, and that's what the formula does. So we know that the formula P squared plus 2PQ plus Q squared equals 1 if we're using decimals, or if we're using percentages, 100%. But this, of course, is what they're asking. The homodom, the heterodom, and the homorecessive. That's the 3 genotypes, and that's what we can find. But in all these occasions, or on these circumstances, we have to find, you can see, using Q, we're going to have to go find P. Because once we have both Q and P, and again, the single Q and P's, then we can just pop them into our formula and calculate any of the 3 frequencies or genotypes of those frequencies. Okay, so step 1, we know that if we have percentages, we have to change that into decimal, right? So that's our first step there. So we take that 30%, and we're just going to divide that by 100 or move it over 2 places to the left, and Q will equal 0.3. Once we have Q, we know that we can easily find P, because we know P plus Q equals 1, or 100% of the population, but in this case 1 for decimal. So we can just manipulate that formula a bit, and we can find P going 1 minus Q. And our Q, of course, is 0.3. Once we do that, we determine that P equals 0.7. And once I have Q and P, and again, this is what we're always going to do for every question. We have to have both P and Q. They'll give you either one of those alleles. You have to find the other using this 1 minus bit, because you do this many times in both ways that they can potentially ask questions for Hardy, but that's how we find the other allele. And once we have both those alleles, pop them into the formula. So if we do that now, here's the P squared. Of course, P squared means P times P, not P times 2. So P is 0.7, and we square that. And when we do that, we find that it comes out to 0.49. And your answer, they want it into the nearest whole percent. So again, if you're going to do all this work, make sure you are putting the answer into what they are requesting from the question. So this one, they want a percentage, 49%. Okay, do the same thing for this. 2 times P, and of course we just determined the P is 0.7, times Q, which 0.3 is what was given in the question. So when we use this, calculate that, it comes up to 0.42, or 42%. And the last one, Q squared, so 0.3 squared, turns out to be 0.09, or 9%. So what we said is that if you add up all of these decimals, should come up to 1 or close to it, because you got to remember sometimes we're rounding off in questions. Or if you add up these percentages, should come up to 100%, and we know we've done this correctly. So that is your 3 frequencies, 3 genotype frequencies for this question. Okay, any question, guys, just give me an email and we can go over some of this stuff. Thanks.